Hello everyone. Today we will talk about conditional execution. We will start from discussing Boolean expression and we will look into the different operators comprising comparison operators, logical operators. And then we will come towards our actual topic, that is the conditional execution. And we will also look into the different versions of this conditional execution, including alternative execution, chained conditional execution, and nested conditional execution. Boolean expression. A Boolean expression is an expression that is either true or false. The reason that I'm talking about Boolean expression right now is that later on we will go towards the conditional execution. And in the conditional execution, we actually check the conditions. And using the Boolean expression, this is the best way to express those conditions that we will work on. And the beauty of the Boolean expression is that it will result in two forms. Either it would result in a true or it will result in a false. And these Boolean expressions actually contain some relationship. We are going to check the relationship between the two operands using one of the operators. Example. This is one of the example that we are using the equality sign over here. This is the comparison operator and it is used to compare two operands. It produces true if they are equal. It produces false if they are unequal. So whenever you see this double equal sign, it is basically used to check the left hand side and the right hand side, whether these two sides are equal or not. So basically these are the operands that we check the operands, and with this double equal sign, which is the comparison, it is the operator which operate on these operands and checks the relationship, compares them, that whether they are equal or not. Example is that 5 equal to 5, and as these are equal, so it will result in true. 5 equal to 6, this is not equal, so it will give us false result. You can check the type of true and false. You can see that type function has been used and the result is that it shows that it belongs to bool. Bool is actually represent the boolean. So for both true and false, we get this bool. Comparison operators. The double equal operator is one of the comparison operators which we talk about right now. The other comparison operators are x not equal to y, x greater than y, x less than y, x greater than or equal to y, x less than or equal to y, x is the same as y, x is not the same as y. So other than equality operator, we have other operators too, which will result either true or false. So here you can see that both the operands x and y, their relationship have been checked. Actually, x and y contain some values. These are variables, and we have already assigned some values to x and y. And depending on the value they contain, their relationship has been checked. You can see that if the value of x not equal to y, then it will give us true result. And if the value contained in x is greater than y, the value contained in y, then it would result in true. Similarly, let's suppose this would become false. If it's true, then it might be false. Similarly, it would check other conditions too, but the main thing is that they are going to check the values that are contained within this x and y, as we have used the variables over here, but you can directly check the values as well. So both the variables containing the values and the values itself can be checked using the comparison operators. Logical operators. There are three logical operators: and, or, not. So basically logical operators are used to check the logic between the operands, and mostly we have seen that we are going to check the logic between two Boolean expression or even more than that, depending on the situation, depending on the problem you have. Now we will talk about and, or, and not. In and, if we have two operands, then the result would be true only if both the operands have the true result. And if either one of the even if one of the operand have the result false, then the complete result would be false. So easily you can examine that if you have 0 and 0, the result is 0. 0 and 1, the result is 0. 1 and 0, the result is 0. And the result is 1 only if you have 1 and 1. So if you have the true result and true result, the final result would be true. Now come towards OR, and in this case we have the same Boolean expression. If one of the result is true, we can get the result as true. So if we have 0 or 1, it result in 1. 1 or 0, it result in 1. If we have 0 or 0, the result is 0. And if we have 1 or 1, the result is 1. So this is how this happens if either one of the operand or if one of the result out of the Boolean expression is 2 or 1, the final result would be 1, or you can say that it's true. Now come toward the third logical operator, which is NOT, and this NOT operator can be applied to the final result. Let's suppose the final result after the computations of the Boolean expressions, and maybe we have also applied other logical operators, and at the end we get some result. Let's suppose we get a result as true. Then in that case, if we apply not on it, it becomes false. And previously if it was false, then applying not, it becomes true. So it actually toggles the results. So x is greater than 0. This is one of the Boolean expression, and it result in either true or false. If let's suppose if you have this Boolean expression, then it's must that you have assigned some value to x previously. Then you are going to check the value it contained. If its value is greater than 0 and x is less than 10, if the x value is less than 10. So this is the Boolean expression and this is the Boolean expression. If it's true and this is true as well, then we are going to AND both the results. So if 1 and 1, only in that case we will get the final result as true. Otherwise, if one of the condition of one of the Boolean expressions results in 0 or false, then the final result would be false. So it's true only if x is greater than 0 and less than 10. Now come towards another example. If we have the n modulus 2 equal to 0 or n modulus 3 equal to 0. So there is or have some relaxed criteria. It's not too much strict as compared to the AND logic. It says that if one of the operand, or if one of the result out of the Boolean expression is 1 or true, then it allows you to move further. It gives you the true result. It's true if the number is divisible by 2 or 3. Now come towards the NOT operator, which negates the Boolean expression. So not x greater than y is true if x greater than y is false. So if let's suppose you have the Boolean expression x greater than y, and it becomes false, and when you apply not on the false result, then only in that case you can get the final true result. So this is quite simple. In Python, any non-zero number is interpreted as true. So it's very important to note this point, that not only true is considered as true, we have the value 1, which can also be considered as true, and we also consider any non-zero number. It can be considered as true. As you can see in this example that we have this digit 17, which is one of the non-zero number we have used. We can easily apply that non-zero number along with this true, and we have applied this logical operator and over here. So 17 would be considered as true. So true and true, the result would be true. Conditional statements check the conditions and change the behavior of the program accordingly. So basically in conditional statements, we have to check the conditions. The conditions that is basically expressed by the Boolean expressions, and those Boolean expressions results in either true or false. And if it's true, we have to execute one block of statements or the one set of statements. And if it's false, we have to execute the other set of statements. So it actually changed the behavior of the program. So depending on the result of these Boolean expression, the behavior of the program changes, the flow of control changes, it alters the sequential flow of execution. Now come toward one of the example. You can see that we have this example in which we have if x greater than 0 full colon, then we are going to print x is positive. So it's quite simple. You can see that if you are talking about conditional execution, then for that we have to use this keyword if. So this is the main keyword if, which is used to check the conditions. And which conditions we are going to check, we have basically expressed those conditions using the Boolean expression. So this is one of the Boolean expression, and you know that the Boolean expressions results in either true or false. So if true, if the result is true, then in that case we will execute this statement. And if the condition is false, you will not execute this statement and you will proceed further in your program. It is very important to note that this print statement is not below this if, but there is a little indentation in this statement, and it shows that this statement is associated with the if statement. So this is the flow chart, and you can see that we have this diamond shaped object which checks the condition. So if the condition is true, if the Boolean expression results in true or yes, it will print x is positive. Otherwise, we will move to the remaining part of the program. The Boolean expression after the if statement is called the condition. We end the if statement with the semicolon character, and the line after the if statement are indented. If logical condition is true, the indented statements get executed. If the logical condition is false, the indented statement is skipped. The indented block containing more than one statement are also called compound statement. So if we have one statement, it's okay. But if we have multiple statements, then those statements would also be indented, and the whole intended block would be comprising of the compound statements. That is, more than one statement would be there. There is no limit on the number of statements. Moreover, we have the past statement. It can be used as a placeholder for code you haven't written yet and does nothing. So if you have certain thing in your mind and you don't want to write the corresponding statement right now, like if you are going to check, you know that you are going to check the conditions that if x is less than 0, but here at this point you don't want to write the action that will be performed, the statements that will be executed. So in that case, you don't need to leave this space blank, otherwise it would be going to give you the error. Instead of that, you just write over here pass. Enter an if statement in the Python interpreter. So the prompt will change from 3 chevron to the 3 dots. Indicates that you are in the middle of a block statement. Consider this example. You can see that we have assigned 3 value to x, and we are going to check this value the x contains. So it's very important point that first of all you have to assign some value to x, and then you are going to check this variable, but actually you are going to check the value which contains. So this is basically 3 is less than 10. So if its condition is true, only in that case we can print on the screen small. And after that we have this dot sign instead of these chevrons. So if you leave it as blank, or if you leave it empty, you can get the result on the screen. But if you want to do something more, after that you have to write the statements right below this point, if you want all these statements to be executed under this if statement. And if you don't want this, then you have to, if you want that only this one statement should be executed, then it's okay. You just have to leave this space empty. Don't consume this space or don't write any other statement over here. Otherwise, you are going to get a get an error at this point. When using Python interpreter, leave a blank line at the end of a block. Otherwise, Python will return an error. So this is one of the example that x equal to 3, and we are going to check the condition that whether x is less than 10. Then we have to print the statement small. But instead of leaving this space as blank, what we are going to do is we are again writing any statement like print done. So what happens after that? When you write this print done, it would give you an error, and it would be the invalid syntax error. Alternative execution. A second form of the if statement is alternative execution. So there are two possibilities and the condition determines which one gets executed. So depending on the conditions and the result we get at the end of the checking the conditions, it would be either true or false. So if it's true, then the corresponding statements would be executed. The corresponding statements which relates to if statement would be executed. Else, otherwise, other statements would execute. So this can be easily done in Python. You can see that we have the same if statement over here. We have used the same keyword if over here. Then we are going to check the Boolean expression. After that, we have this full column over here. So if this expression is true, then we will print x is even. So if the result is false, then automatically it will go to this part and it would print x is odd. So basically we have two branches, this one and this one. So depending on the result we have out of this Boolean expression, we can print these sentences. This is the flow chart, and you can see that we have two branches over here. We have the same diamond shape used to check the Boolean expression, whether it's true or false. So we are going to check the Boolean expression over here. It would result in either yes or no. If it's yes, then we will print that x is even. And if it's false or no, it would print on the screen that x is odd. Exactly one of the alternatives will be executed. The alternatives are called branches. So you can see that we have two branches over here at this point, and we have to select one of these branches, and then this is basically depend on the result of the Boolean expression. So we have these branches, and these branches are in the flow of execution. Change conditional. Sometimes there are more than two possibilities, and we need more than two branches. One way to express a computation like that is a change conditionals. So this is one of the example. You can see that in the previous first of all we talk about if, then we have some extended version in which we talk about if else. Now you have the if else if, and then at the end you have this statement of else. Now if using if statement, you are going to check the Boolean expression x is less than y, so it would be either true or false. Then if it's true, then it only in that case it will print x is less than y. And then else if another condition is going to check the whether x is greater than y, so it would be print on the screen that x is greater than y. If none of these cases are true, then it will come towards the else part, and in the else it's printing that x and y are equal. Elif is an abbreviation for else if. Again, exactly one branch will be executed. There is no limit on the number of if statements. If there is an else clause, it has to be at the end. So if you are going to talk about the else, then it has to be at the end, but there doesn't have to be one. If choice equal to A, then we have to print bad guess. Else if choice equal to B, then we have to print good guess. Else if we have the choice and which is equal to C, Then you have to print close but not correct. Each condition is checked in order. So if you are going to check these conditions, then you have to go in order, not out of the order. If the first is false, the next is checked, and so on. If one of them is true, the corresponding branch executes and the statement ends. Even if more than one condition is true, only the first true branch executes. Nested conditionals. One conditional can also be nested within another. If we talk about nested structures, it means that there is a structure within another structure. Here we are talking about nested conditionals. It means that the conditional block contains another conditional block. And we can have multiple nested conditional statements. That is a block within another block, and in that block we may have another block. Here is 3-branch example. If you can see that if x equal to y, it means that if we are going to compare these two values and if they are equal, then this statement will be executed, which will print x and y are equal. Else we go to the other branch, in which in this branch again we have if-else statement. So if this is true, only this statement will be executed. If it's false, then it would not be executed, and we will come into this branch, that is the else branch. And we observe that in else branch, we have another if-else statement. So if x is less than y, it will print x is less than y. Else it will print x is greater than y. It means that if this condition is true, only this statement will be executed. If it's false, then we have again two possibilities that either this would be executed or this would be executed. Logical operators often provide a way to simplify nested conditional statements. Now, in this, we will observe that how it would be a simple problem, how it would become a simple way to use the logical operators, and it is actually the replacement of those complex nested conditional blocks. So using the logical operator, we can simply replace this nested if statements. Like you can see that if x is greater than 0, and within, if this condition is true, then we again can execute this if x is less than 10. So if it's greater than 0 and it's also less than 10, only in this condition x is a positive single digit number. This would be printed on. So this would be printed on the screen if this is true and this is also true. So this can simply be replaced by using this AND operator. You can use this condition and this condition. So in that case, only this would be printed on the screen. So we can get the same effect using the AND operator. You can also see the flowchart of that. First of all, we will come into this condition, checking that x equal to y. So if this is true, then we will go to this branch, and if it's not equal, then it will go to the other branch. So consider that this is the if statement. So if it's true, then it will come towards, and if it's no, then it will come to the other side, which is the else branch. And within the other else branch, we observe that we have another if-else statement. So another statement, another Boolean expression we are going to check, and if it's true, we will go to this side, and if it's not true, it's false, then we will go to the other side, the else side, and then we can continue the rest of our program.